Hey guys, I've been finding that a lot of people are struggling with example 4 on our chapter 3 calculus review. It goes over optimization problems. So I'm making this video just to give you guys a definition for what it means to optimize something. And I'm going to go over a heavily requested example 4C, to hopefully get you guys um, through the door and give you guys a good chance on this next test. So, what is optimization? Simply put, optimization in math means to find the value that maximizes or minimizes something. To do either means to maximize or minimize, but both are considered optimization. So, how do we do this? By finding your relative extrema, that is, setting your derivative equal to 0 and finding these values that optimize your function. So that's all that optimization is. So I'm just gonna erase this, get example 4C on the board, and um, I'll get you guys started. Alright, so problem 4C states, a window maker will use 600 inches of aluminum strips to build the frame of a window in the shape of a semicircle on top of a rectangle. Find the dimensions that maximize the area of the window frame. So right off the bat, this is a lot of information. So let's break it down. So what it's asking you to find is the dimensions that maximize the area of the window frame. So right off the bat, I know that this is an optimization problem because of language like maximize, minimize, optimize, shortest, greatest, that kind of stuff is a hint that it's going to be an optimization problem. All right, so to find the dimensions of the window frame, we got to know what the window frame looks like. And thankfully it tells us right here that the frame of a window, this window, is going to be in the shape of a semicircle on top of a rectangle, right? So all that means is that it's going to be a rectangle and it's going to have a semicircle on it. A semicircle is just half of a circle, and it's not going to be that kind of line. Is going to be a dotted line because this isn't part of your perimeter. All right, speaking of 600 inches of something to build the frame. So frame, that's going to be the perimeter of your window, and you're going to have 600 inches of it. So right off the bat, I can give the statement P equals 600 inches, just right off the bat. All right, so if we're going to find dimensions of this window, we're going to need some variables for it. I like to use base and height. This is a rectangle, so both of these heights will be the same. This base will also be the same, again, because this is a rectangle, but that's not very useful to us. It's just not necessary to have it. You could think of this more so as the diameter of this semicircle. A diameter is just where you go from one point on the circle to another point through the center. But again, that's not very useful for us. It's not important in like equations and stuff for circles. But what is your radius. And your radius is just half of your diameter. So if your diameter is b, then your radius is just b over 2. All right. So I'm gonna write this on the top. I'll erase this problem. Hope you guys have it like either copied down or just like in your head. Because at this point I'm gonna start optimizing, which is gonna be all work. And so I'm gonna need space for it. All right, so you want to keep your diagram in a corner somewhere, more so out of the way from like the rest of your algebra. I also erased the perimeter and just put it up there. All right, so let's start off with an equation for area. So what's your area? It's just going to be the area of this piece plus the area of this piece. So I'm not sure if I said this earlier, but a semicircle is just half of a circle. So when we're finding the area of this piece, well, the area of this piece, that should be pretty easy. It's just base times height. But we're also adding the area of this piece. And the area of this piece is just going to be the area of a circle, pi r squared, but half of it. Because again, this is just half a circle. So same logic as a triangle. How a triangle is 1/2 base times height. It's like a square cut in half. A semicircle is just a circle cut in half. Plus half pi r squared. All right. So we have an equation for area. This is what we're going to want to maximize. But we have a problem. I count 1, 2, 3 variables. So we got to get something in terms of something and something else in terms of that same thing, so that we can derive it without having issues, without having to use implicit differentiation, without any of that. So I am going to get, how about everything in terms of r? Because I feel like that'd be pretty easy, because anything else you'd have to substitute into r, and then you'd have to square it, which can get a little annoying. So first, let's get our b in terms of r. So times 2 times 2. B equals 2r. Right? All right. So we have our b. That wasn't too bad. But now we're going to need our h. And that one's a little harder. We'd like to get h in terms of b or r. If we get it in terms of b, we could just substitute this in there to get everything in terms of r. So it doesn't really matter which one we're going with. I'm just choosing to put everything in terms of r. So I will be finding either this one and having to convert it into r, or finding r directly and just plugging it straight in. So we have this perimeter, and from here we could find the perimeter of this whole thing. So that's going to be your base plus both of your heights. So you have two of the same thing, and each of them are added to each other. H plus h, that's going to be 2h. And then you're also going to be adding your circumference of your semicircle. So the circumference of your semicircle is just the circumference of a circle squared. Or not squared, half of that. Squared is very much not so. So your circumference of a circle is 2 pi r. So half of that, well, you'll have 2 pi r over 2, and your 2's will cancel. So all you're really left with is pi r. Great. Now we can plug in p and get 600 equals b plus 2h plus pi r. Okie dokie. We can get b in terms of r. So 600 equals 2r plus 2h plus pi r. Neat. But we have 600 equals like this mess. But what we can do from here is we can solve for h. That's going to be our goal, so that we could plug it back in here and get everything in terms of r. Because we already have b. If we get h2, then we'll have everything in terms of r, which is very useful. So subtract. All right, so there's a little cut there. That's because I ended up subtracting both sides by the wrong thing. And so it just wasn't correct. So I'm just gonna try this again. That's 2r minus pi r. Shouldn't be too much different for you. Maybe some of the writing looks a little cleaner, a little bit of a different spot. But in general, yeah, and tone of voice. 300 minus r minus pi over 2r. So this is h in terms of r. So now that we have everything can be converted into terms of r, we're going to do just that with our area equation. So all this stuff, not really. Well, it is kind of useful to know where it came from and to show work, but I need the space. So out with it. So a equals b will just be 2r, and then h will be 300 minus r minus pi over 2r plus 1/2 pi r squared. So because we're going to end up deriving this, because we're trying to find relative extrema, right? That's what optimization is. It's going to be easier just distribute this and derive each term rather than use product rule. So you'll end up with 600r minus 2r squared minus the 2 here and the 2 here are going to cancel, so pi r squared. And you can put the pi in the numerator, so pi over 2r squared. So you can actually combine like terms here. You have terms of pi r squareds. So you have -1 pi r squared plus pi over 2 r squared. So you could think of this as 2 pi over 2 r squared, and adding up like terms, that'll just give you 2r squared negative pi over 2r squared. And now I'm gonna put this h function, not function, equation over here on the bottom, just to make some more room to derive. So it shouldn't be too bad. A prime is just 3 terms, 600 minus 4r minus the 2's here are going to cancel, because it's going to be 2 times pi over 2 pi r, and set this equal to 0, because remember we're trying to find our relative extrema. Pi r, subtract 600 from both sides, you end up with -4r minus pi r equals -600. Factor out a -r. You're left with 4 plus pi equals -600. Divide both sides by -4 plus pi. -4 plus pi. 4 plus pi cancel. Negative cancels. Oops. 4. There we go. So your negative over negative is going to turn positive, and r ends up equaling 600 over 4 plus pi. which is nice. Good to know. But it's not one of our dimensions, so that's not too bad, because b is just 2r, and then we could solve for this. So now we just have to verify that this is indeed a maximum. So actually, I probably shouldn't have erased my derivative, because that's what we are going to use to find out if this is a relative max. Hold on. All right, so you can do one of two things. You could use the first derivative test, or you could use the second derivative test. I prefer the second derivative test in this situation because, look, you got 3 terms. One of them is constant. That's just going to turn into -4 minus pi. And you'll find the same information whether it's a relative max or a relative min, either way. So -4 minus pi, and that's your second derivative. Now, simple, right? So you have a negative number minus another number. So no matter what, this is negative. There's no variables in it, so this is just a constant negative slope. So what this tells us, what all this information tells us, at r equals 600 over 4 plus pi, we are going to have our slope, this is for your first derivative, equals 0. Our second derivative says that throughout the entire function, you are decreasing. So we can think of this relative to 0. So if it's decreasing, then that means that after 0, it's going to go and become negative, our first derivative. Likewise, since it's decreasing and it reaches 0, then everything before must have been increasing. So what do we have here? We have our first function, because our second derivative is just the slope or the rate of change of our first derivative. So our first derivative, it can be like a function. This could be a relative max. So our first derivative will look like this throughout, and then it's going to go down there. But our second derivative will say, hey, it's decreasing this the entire time. So that's how we can figure out, hey, this is a relative max, which is what we're looking for, which is a good sign. So we verified that this is a relative max. Now to just find our dimensions to maximize area, which shouldn't be too hard. B is just 2r, and then r is just 600 over 4 plus pi, so multiply across. 2 over 1, that's going to be 1200 over 4 plus pi. Where are your units? Inches. Boop. And you got your base, just like that. And then height isn't the hardest thing in the world to find. Gonna make myself some more space. You guys probably shouldn't be erasing stuff as you go along, but I got a whiteboard, so privileges, right? H equals 300 minus r minus pi over 2r. Man, that's starting to get a little bit rubbed out. All right. So H equals 300 minus 600 over 4 plus pi minus, you're going to have 600 times pi, but that 600 is going to be over a 2, and that 2 is going to multiply by 4 plus pi. So you can actually reduce here. 300 pi over 4 plus pi. Written out, this is 600 over 4 plus pi. So these would multiply across. So you'd end up with 2 times 4 plus pi, and this being under this. So your 2 can cancel out with a 2 that you can factor out here. You'll end up with 300. You're just reducing. If you don't know what, like I just said, layman terms, you just reduced. These are already in common denominator form, and you're subtracting them, so that's what you would need. So in this case, it's pretty simple. 300 plus negative 600 minus 300 pi over 4 plus pi. All right, this is an answer. So I'm going to actually give it the honor of being written again. 1200 over 4 plus pi inches. And now for h. Now that I have the space for it. So this 300, we want to add it to this fraction, but we need a common denominator. So 300 times 4 plus pi over 4 plus pi. This 300 is just going to distribute to each term. 300 over 1. This 4 plus pi is just going to stay in the denominator. So all this over 4 plus pi. 300 distributed to 4 is 1200, or multiplied by 4, plus 300 pi, because it's just 300 times pi, minus 600 minus 300 pi. Looky here, you got like terms, and they're the same value, or the same magnitude, but different signs, opposite signs, sorry. So they just cancel. H equals, and then we got like terms again here. So this ends up being, when you add it up, 600 over 4 plus pi. This is inches, and you are done. You have done 4C. Congratulations. Hope you guys have a good day. Hope this helped. Hopefully you won't need me and I won't see you next time, but if you do, hope you're not super stressed out about the test that's probably coming up. All right, have a good day.